What people will generally do the first time they're asked to multiply two matrices is they'll multiply this number by this number and put it here, multiply this number by this number and put it here, and this number by this number and put it here, and this number by this number and put it here. That's not right. That's not what you do. Okay, as I said before, we multiply rows by columns. There's no such thing as multiplying a number by a number and getting something to put over here. We do multiply numbers by numbers, but we add them to other numbers to get these. The result of the multiplication is this, and let's see how that result comes about. Okay, we got to multiply rows by columns. So we got a first row times the first column. We could do a first row times the second column, a second row times the first column, or a second row times the second column. And it turns out that we do all of those things. Whenever we multiply two matrices, we multiply every possible row by every possible column. And then to keep things straight, we put them in another matrix, and the position of a number in this matrix, it has a row and a column. For example, this number is in the first row, second column. And this number comes from the multiplication of the first row by the second column. So if it's in the first row, second column, it comes from multiplying the first row by the second column. So that when we multiply, let's say, the second row by the first column, where's that going to go? Well, it's got to go into the second row here and the first column, which is here, the 3.34. Okay, well, let's just review how we multiply rows by columns. Multiply the first row by the first column. What are you going to multiply by what? Well, the 0.80 times the 0.80 and the 0.10 times the 0.20. And that's what we do. 0.80, 0.10 times 0.80, 0.20 is going to give us 0.80 times 0.80 is 0.64, 0.10 times 0.20 is 0.02, giving us 0.66. Then we multiply the first row by the second column, this by this, and here's what we get. You can check this out. Second row by the first column gives us this, and the second row by the second column will give us the 0.83. And you can see what those numbers are, and you can check it out. We'll just zoom in on it. Well, too far. Zoom in on it a little bit here anyhow, so you get a good look at them. You can pause that there and take a look and just see where you think things come from. We're going to move on now. Okay, now recall that to get our second year population, we multiplied the 524.80 that we got at the end of the first year by the transition matrix. Now we were going to multiply this, we hadn't actually done it yet. If we do the multiplication, 0.80 times 520 is 416, 0.10 times 480 is 48, giving us this number here, which adds up to 464. 0.20 times 520 and 0.90 times 480 gives us 104 and 432, 536. Those are the numbers. Now if we take the product matrix, the 0.66, 0.17, 0.34, 0.83 times the 600, 400. You can check the numbers out. 0.66 times 600 is 384. 0.17 times 600 is 0.68. 0.34 times 600 is 216. 0.83 times 400 is 332. We add these numbers up and we get these results. And these results are the same as what we got here. So that this does work. When we take this matrix and multiply it by itself, then times the original population, we get the same things if we take this matrix times what we got when we took the same matrix times the original population. If you can sort that comment out.